So this table from Revised National Plumbing Code of the Philippines, ito yung sa plumbing ginagamit na madalas is yung fixture units, yung number of bedrooms. Ito, number of bedrooms. Yung ilan yun, may katapat dito ilang gallons. Or number of apartments. Ito rin. So mostly ginagamit ko is yung DFU. Kasi doon sa nakuha mong DFU, drainage fixture unit, makukuha mo yung katapat niyang minimum septic tank capacity. So yung extra bedroom, extra dwelling unit, extra fixture over 100 kasi 100 lang to. So yung dadagdag mo. Or by water flow rates method. So by method, ito, pagbibilang ka ng ilang tao, ilang lane, bawa to, sa dance hall, ilang tao, sa hospital yan, ilang bed. So pwede rin to. Kung ano yung mas malaking nakuha mo, so yun ang gagamitin mo. Kasi ito, hindi makakatanggi, naka-install na yung mga fixture units mo, ay yung mga fixtures. So yan, extension to. Schools, stores, nandiyan lahat. Okay. Pag-compute mo rin ng wastewater, ito rin ang gagamitin mo. Sa plumbing code natin. Sa ibang code, meron din sila. Merong parehas, merong iba. So take note. So design, mga sample design ta ng septic tank. Example, for 2 compartment or chamber septic tank. Example is ang DFU total mo is 27. From Revised National Plumbing Code, Table B to Annex P27, 183. 27 DFU, so if interpolate mo, lalabas is ilang gallons? 127 gallons or 4826 liters. Minimum in the plumbing code. No septic tank sizes. Sinulat ko lang yung notes doon. Table B2. Now, pag-compute the inlet compartment volume, yung first compartment, that is 2/3 of the total capacity. So this is 2/3 of 4.826 cubic meter is 3.217 cubic meter minimum. So this is also above 2 cubic meter. So approved. Use width 1.8 and length 1.5. So this is pag pwede ka mag-assume na yun, pero kailangan i-double check kung pumapasok dito sa rules na. Okay, so ito ang pumasok sa rules. So 1.8 width, yung width inside at inside. Ito kasi mga 150 mm ang ticket na 100 ng concrete hollow blocks. So depth is 3.217 over 1.8 over 1.5 is 1.2 meters, so less than 1.8 meters maximum. So volume of inlet compartment is 1.5 times 1.8 times 1.2 is 3.24 cubic meters. So this is slightly above. Check for the total volume. So each additional compartment 1 cubic meter minimum to 1/3 of 4.826 cubic meter is 1.609. So yan yung 1/3. That is, ito yung ano mo. So width is 1.8 meters, depth is 1.2 meters, length is 1.609 over 1.8 over 1.2 is 0.745 or 0.8. Any method, basta magtali ka. Any manipulation ng calculation mo. Okay? Basta magtali ka lang yan. So volume of second compartment is 1.8 times 1.2 times 1.8 is 1.73 cubic meters. So slightly above siya. So the total capacity is 3.24 plus 1.23. So this is also second compartment is above 1 cubic meter. So total capacity is 4.97 cubic meter is greater than 4.826 yung required. So inside dimension with 100 mm wall thickness plus 300 mm freeboard. Freeboard tabi yan, yung walang tubig. Yung water level, digestive tamper, dito yung mga sludge. Lalaglag yung mga human waste. Dito magiging tubig siya, tapos lipat doon. So, ito yung iba, butas to. Iba, sarado. Okay? Gano'n siyang outlet dito. Yan. Diba? Bawal yan. Manhole. Nakalagay naman sa plumbing ko kung ano yung size. Minimum. So, actual volume of inlet compartment is 1.5 plus 1.8 plus 1.2 is 3.24. Second compartment, actual siya, 1.2 minus 0.05 kasi ito, dapat 2 inches. Ang difference niya, di ba? Every chamber, 2 inches. So, inches is 0.05 meters. So, minus 0.05, yung height na 1.2 minus 0.05, ito yung height na. Plus 1.8 times 0.8 is 1.66 cubic meter. It's greater than 1 cubic meter. Inaan natin ito, hindi kasama ito. It's greater than 1 cubic meter. So, actual capacity is 3.24 plus 1.66 is 4.9 cubic meter, or 4 is still greater than 4.826 cubic meter. Okay. This is less than 1/3. 4.9 divided by 3 is dapat bisa 1/3 siya. Okay. Now for the 3 compartment chamber septic tank, design 1. Design 1, ito yung horizontal. Ito naman yung box type. Kasi meron tayong minimum na for over 6 cubic meter capacity, secondary compartment may not be less than 1.5 meters. So mahaba yon. So pag nag-compartment ka, magwa 1.5 saka 1.5. So instead na, tapos di mo makuha yung 1/3. Instead na ito, dalawang 1.5, pagtabi mo na lang yun, makukuha mo yung sayang ng ito. Yan. 1.5 ito, same siya, 1.5, masunod yung goal mo. So ito naman is less than 1/3. So ang capacity ng 3 compartment is ito saka ito. Yan lang ang capacity. Ito is extra na lang yan. Sabi kasi ang additional compartment is same size ng secondary compartment. So kahit chinek ko doon sa sa standard, ang catalog ng nakita ko, ito yung capacity. So bawa dito 16 DFU palitin natin. 16 DFU is 800 gallons. So inlet compartment volume is 2/3 of 3.028 cubic meter or 2.019. So this is less than 6 cubic meter. Use width 1.1, length 1.5. So depth is 2.019 over 1.1 plus 1.5 is 1.224. Use 1.25. Manipulated na to para magtali dito. So volume of inlet compartment is 1.5 plus 1.1 plus 1.25 is 2.0625 above. Okay. Still greater than 2 cubic meter. Check for total volume. Each additional compartment is 1 cubic meter. Width is 1.1 meter. Depth is 1.25. Length is 1/3 of 3.025 over 1.1. 1.25 is 0.734. Use 0.75. Example na to, kinuha ko lang sa mga project ko kaya siya magulo. So volume of each additional compartment is 1.1 plus 1.25 times 0.75. Itong kinuha mong value is 1.031. Now, 1/3 of the total capacity of the tank is 1/3 times 2.0625 plus 1.031 is still 1/3, 1.031 cubic meter. So, okay, it's greater than 1.0. Now, the inside dimension of 100 mm with 100 mm wall thickness plus 300 mm freeboard, H is equal to 0.3 plus 1.25 is 1.55. Kasi ito yung depth mo. Plus 0.3. So ito yung inside dimension mo. So width is 1.1. Yeah. So length is 1.5 plus 2 times dalawa yan, times 0.1 yung 100 mm plus 0.75 times 2. Times 2 kasi ito 0.75 saka 0.75. So the actual volume of inlet compartment is 0.0625. Second compartment, nagbaba siya ng 50-50. So this is now 1.25 minus 0.05 times 1.1 times 0.75 is 0.99. It's less than 1.0 cubic meter. Third compartment, ganun din, less than. So we adjust again. So width 1.1, length of the first compartment is 1.5. So adjust the depth to 1.35. Now the volume of inlet compartment is 1.5 times 1.1 times 1.35 is 2.2275 cubic meter. Is not less than 230. Each additional compartment length is 0.75. Volume of each additional compartment is 1.1 times 1.35 times 0.75 is 1.1138 cubic meter. Now the 1/3 is 1.1138 cubic meters, greater than 1 cubic meter. Okay. So inside dimension with 100 mm wall thickness plus 300 mm freeboard, H is 0.3 plus 1.35 is 1.65 na. Width is 1.1. So length is 1.5 plus 0.1 times 2 plus 0.75 times 2 or 3.2. Now the actual volume of inlet compartment is 1.5 times 1.1 times 1.35 is 2.2275 cubic meter. Second compartment is 1.35 minus 0.05 times 1.1 times 0.75 is 1.0725 cubic meter, greater than 1 cubic meter. So third compartment is 1.35 minus 0.05 minus 0.05 times 1.1 times 0.75 is 1.0313 cubic meter, greater than 1 cubic meter. And the actual capacity is 2.2285 plus 1.0725 is 3.3 cubic meter or 3.028. So yeah, so 1/3 ng tip nyo yung 1/3 ng 3.3. 1/3 ng 3.3 is 1.1. Nakalimutan na rin ang 1. So 1/3 of 3.3 is 1.1. This is maximum capacity of 1/3. So this is okay. So 1.0725 is less than 1/3 of 3.3. Now, 3-compartment chamber septic tank design 2. So total DFU is 39, use 35. Next na yung DFU sa table. Pwede ka rin gumamit ng 39. Gusto mo, interpolate mo lang. So from this is 2,000 gallons, 7,570 liters. Minimum in the plumbing code. Maximum depth 1.8 kasi malaki ito. So kung lagay ng maximum, gamitin natin. Inlet compartment volume is 2/3 times 7.57 cubic meters. Ang gawin ko ito yun. 7,570 liters is 7.57 cubic meter. So 5.05 cubic meter minimum. Use width 1.6. Length is 1.05 over 1.6 over 1.8 or 1.75. Use 1.8. The capacity is more than 6 cubic meters. So the other compartments is not less than 1.5 meters. So use 1.85. Manipulated na to. Check for total volume. Volume of each compartment is 0.5 times 1.85 times 1.85 times 1.6 minus 0.1. Ito yung 0.1. Ang width mo is 1.6 to 1. Yan. So ito 1.6 minus yung thickness ng partition, 0.1. Yan. 7.6815 cubic meter. Ito. Itong 0.5 is kalahati. Hindi ito, 1.6 minus yan, divide by 2. So 0.5 to. Ito yung depth, ito yung length. Okay? Makamali ito kayo kung saan galing yung 0.5. So still, total volume number is 1.8 times 1.6 times 1.8 first compartment plus 0.5 times 1.8 plus 1.85 plus 1.6 minus 0.1 is 7.6815. So more than 7.57 cubic meter. And the 1/3 is 2.2275. 2.5605 greater than 2.025. 1/3 ng 7.6815. Okay. Inside dimension with 100 mm wall thickness plus 300 mm freeboard. H is 0.3 plus 1.8 is 2.1. Width is 1.6 or 1.6 meter. Length is 1.8 plus 0.1 plus 1.85 is 3.75. Yeah. Actual volume of inlet compartment is 1.8 times 1.6 times 1.8 is 5.18 per cubic meter. Second compartment, 0.5 times 1.8 minus 0.05 times 1.6 times 1.85 is 2.43 cubic meters greater than 1.0. So wait. So second compartment, 0.5 plus 1.8 minus 0.05 plus 1.6 minus 0.1 plus 1.85 is 2.43 cubic meter. Third compartment, 0.5 plus 1.8 minus 0.05 minus 0.05, 1.6 minus 0.1 plus 1.85 is 2.36 cubic meter. Both greater than 1 cubic meter. Actual capacity is 5.184 plus 2.43 is 7.614 cubic meter. It's less than 7.5, oops, greater than 7.57 cubic meter of water. Wait. Yeah. So 1/3 of the actual capacity is 7.614 over T is 2.538 cubic meter. Is greater than 2.43 cubic meter. Okay. Kasi dapat doon hindi siya lumampas ng 1/3. Ito. Dapat ang isa. So hindi nga siya lumampas. So ito yung section niya, ilalagay niyo sa plano niyo. Kasama sa plano yan, mga drawing na yan. Pati itong bars na yan. So ito yung septic tank. Galing doon sa mga drainage mo, punta doon septic tank. Nakalubog yan. Ha? Dapat nga mayroong isa yung invert ng level, elevation. So ito yung location ng septic tank mo. Andito yung, dito na ito mga CB kaswisi niya. Ito yung drainage mo. Ito yung symbol of growing. Ha? Hindi lang basta tusok-tusok yan. Pero ayan, floor drain, mayroong trap, mayroong clean out, kitchen sink, meron sa mga commercial, meron din tawag na glass trap. Ito yung laboratory, water closet, shower. Ito ang symbol ng shower. Punta doon, so 4 inches, punta na siya sa septic tank. Tapos tapon. Okay? Yan ang drawing. Isometric, mag-isometric kayo. Kaya check niyo yung mga reference kung paano mag-isometric. Huwag niyong gayahin yung floor plan, tinatabingin lang. Diba? Mali yun. Kasi pag lagay mo na yung water closet mo, laboratory mo sa floor nakalagay. Yung tubong closet mo sa taas. There are 4 principal systems of plumbing for drainage of building. So meron tayong single stack system. Andiyan lahat. Pero ito yung pinaka not recommended. This is the simplest system in which the waste matter from baths, sinks, etc., as well as foul matter from the water closet are discharged into single pipe called the soil and waste pipe. This pipe terminates as the bent pipe at its top, and no separate bent pipe is provided. The single stack system is effective only if traps are filled with water seal of depth not less than 75 mm. So hindi siya 2 inches, dapat 3 inches. Gully traps and waste pipe are completely left out. The system is simple and economical since only one pipe is used. Ito, figure A. One full septic tank yan to drain. Ito kasi, yung vent mo, hindi siya makalabas kung ito nag-drain. Ano yan, sa vent. Or tapos, malaki yung ito. Septic tank, madali mapuno. Kasi lahat ng shower mo, laboratory, pumapasok doon. Pupuno yung septic tank. Wala kang option na itapon sa iba yung drain. One pipe system. So ito, separate naman ito. In this system, separate bed pipe is provided and the trap of all water closet basins, etc. are completely ventilated. So lahat ng vent niya, papasok ko sa isang vent lang. So walang sasalubong sa'yo drain. In a multi-story building, the laboratory blocks of different floors are situated one above the other so that discharge from various units at different floor can be carried through common soil and waste pipe. The system is costlier than the single stack system dahil may additional vent na. So ito. Next, single stack system partially ventilated. This is modified form of the single stack system and one pipe system. In this system, the waste from water closet, basin, sink, and S sink and the shower, etc. is discharged into one common soil and waste pipe. However, in addition, a relief vent is also provided, which provides ventilation to the trap of the water closet lang. Yan. Separate niya. However, in addition, a relief valve also provided. The traps of basin, etc. are not directly connected to the vent or pipe. Pwede to yung pagkatingin sa vent, topic namin, merong individual vent tawag. But for the two pipe system, in this system, separate soil pipe and waste pipe are provided. The discharge from water closet is connected to soil pipe, but the discharge from bath, sink, lavatory, basin are connected to the waste pipe. Also, so waste from urinal andun din sa soil pipe. All the traps are completely ventilated by providing separate ventilating pipes. Thus, 4 pipes are required. The discharge from waste pipe is disconnected from the drain by means of a gully trap. Sometimes, may mga project ako na nag-design mo, mag-request sila kung pwedeng hiwalayin kasi nga dahil sa septic tank nila, ayaw nila mapuno agad. So, ngayon, pag na-design mo na itong single, pinapagawa nilang separate, mag-redesign ka ulit. So, yun ang mahirap. So, dapat tanungin mo ng kliyente mo kung gusto mong hiwalay na. Kasi init tapos pwede mo siyang pagsamahin sa isang septic tank or pag pinayagan silang i-discharge sa iba yung mga sa laboratory na wala namang human waste, pwede mo na siyang tanggalin doon. Huwag mo na ipasok sa septic tank. Ihiwalay mo na lang doon sa main drain. Diba? Kasi ito, malinis pa to eh. Pwede pang ibalik. Buhos. Yung mga reuse. Wala tayo sa topic na. Saka na yan. Pag tapos na kayo. alalan nyo na lang yung mga rainwater, na reuse ng water, saka na yun. Kasi ngayon, di pa rin pwede discuss. Kasi pag-aralan pa lang yung paano pag-size. Grease trap or grease interceptor. Plastic grease trap are plumbing fixtures that contains pools of rotting food waste. So yan, kita mo. May mga maliliit yan, lalagay lang sa ilalim ng kitchen sink. Yung mga malalaki sa labas, yung mga centralized. Malalaki is interceptor ang tawag doon, ang maliliit is trap. Fats, oil, and grease, FOG, are lighter than water and float to the top of the tank. Passive grease tank above ground are metal or plastic tank required in food service facilities to prevent fats, oils, and grease from entering the sanitary sewer or septic system. Required yan ng ANR. Lahat ng commercial restaurant required sila. Residential optional. Grease interceptor are large in-ground outdoor tank that prevent FOG and food soil fluid from entering the sanitary sewer or septic tank at restaurant facilities. Yan, malalaki yan. Large. Conventional grease trap are referred to as passive grease trap and gravity-based grease trap. Malaki ito. Dalawang klase ang grease trap kasi. Merong hydro-mechanical. Grease trap were originally designed over 100 years ago. Grease trap technology has remained virtually unchanged since 1880s. This is the passive grease interceptor. So, design ng grease trap. So, kaya na lang research niyan. That is special sa mga food restaurant. Dalawang klase yan. Meron ka makikita ng mga table niya na picture unit. Ang maliit sa kitchen sink, normally require is 15 gallons per minute. Hydro-mechanical. Ayun, tawag doon. Hindi yung gravity. Ang gravity kasi, ang unit niya is in gallons. Ang picture unit, ang equivalent is in gallons. Pag hydro-mechanical, ba yun? Is in GPM. So pag GPM, 15 GPM sa kitchen sink, sa SM, require that. 7 GPM naman sa hand wash. So ito, ayan yung grease trap. Pag hugas ka dyan, simple dito. So lulutang yung ang oil parts mo. So, ang madidrain mo na lang is yung clean water. Next, floor drain. Ano yung floor drain? Sinabi kasi sa drainage kasi importante yung floor drain. A floor drain is a plumbing fixture that is installed in the floor of a structure, mainly designed to remove standing water near it. Naka-stack na tubig. They are usually round but can also be square or rectangular. They usually range from 2 to 12 inches. Most are 4 inches and 10 centimeters in diameter. Depende sa iba. Pag ordinary lang, sa mga bahay, 2 inches. Mga parking, 4 inches. They have gratings that are made of metal or plastic. The floor around the drain is also sloped to allow the water to flow to the drains. Dapat naka-slope. Pero di nakusunod yan. Paglalagay ng floor drain, mas mataas pa sa floor. Diba? Nakita nyo sa net. The floor around many residential basements have one or more floor drains, usually near a water heater or washer dryer. Floor drains can also be found in commercial basement, restroom, kadalasan, kitchens, kadalasan kasi yung mga tapon-tapon, refrigerator areas, locker shower rooms, laundry facilities, and near swimming pool, among other places. A floor drain should always have a strainer secured over it to prevent injury, entry of foreign objects, or introduction of unwanted pests into facilities. However, if the strainer is not smooth enough, hair and other objects can still get stuck and clogging the drain. So ito yung mga floor drain. Ito na yung floor drain detail. Ground floor, second floor. Ito yung mga sample ng floor drain natin. Ang floor drain, may tinatawag na emergency drain. Ito yung mga sa restroom. emergency drain yon. Yung mga sa service sink, map sink, sa ugasan ng yung inaano yung nire-release niya yung mga trapo, yung pinupuna sa sahig, tawag doon is hindi na yon emergency drain. Shower, may drenching siya, so hindi yon emergency drain. Ang emergency drain, yung mga sa tapon-tapon lang. Kasi meron ang laboratory, may sariling drain siya. Yung sa floor drain is in case na may matapon lang doon. Kaya nga tinawag na emergency drain. Hindi siya dedicated talaga. So this is the end of the topic, and see this sample isometric diagram with legend. Ganito ang mga gagawin nyo sa pag-drawing. So dapat magaling ka rin mag-compute. Saka maglagay ng mga type signs. 1-in-1 of BTR. Wala nang dating 2 inches ang available sa atin. Okay? Pin out. Pin out. So minsan pag wala ka nakita niya, so automatic, lagyan mo na lang pa nag-estimate ka. Yan. So, ganito ang gagawin nyo pag isometric. Dapat makagawa kayo. Okay? Thank you very much.